Hello again, making one more video, most likely my last one. But I wanted to make this video because I think I came up with a pretty good experiment or argument to explain where the 4 times the energy is hiding when we have twice the spring displacement. And this involves only very simple experiments that anyone can do at home. No velocities, no accelerations, no complex mathematics or units. Just some spring displacements and spring constants. That's all, very simple. So to do these experiments, you need two identical springs, some weights, and maybe some string or steel wire to tie things up. First, you start with just one spring. You load it with one mass object, measure the displacement, let's say it's 1d, and then you connect the two springs in series like this. So you attach one spring to the end of the other one and load the whole spring system with the same weight and measure the displacement. My prediction, and I also think the prediction of conventional physics, is that the displacement should be twice as much. It should be 2d. Because both of these springs, the red spring and the blue spring, they feel the same weight. They feel the total weight of this object. So they both have a displacement of 1d, which in total is 2d. But of course, don't take my word for it. If you're skeptical, this is very easy thing to check for yourself if you want. But if you do, it should prove our proposition number 1, which is that when two identical springs are connected in series, the spring constant is halved. Or vice versa, when a spring is cut in half, the spring constants of the pieces will be doubled. Next, you do almost the same thing, but you load the two springs in parallel, so side by side like this. Maybe this is a bit more intuitive, but now I think the displacement is only half of that of the only one spring. Because now these two springs are sharing the weight of this object, so each of them is loaded by just 1/2 of the mass, and thus the displacement is only 1/2. And again, this is quite easy thing to check for yourself. And it should prove our proposition number 2. When two identical springs are connected in parallel, the spring constant is doubled. And now we have two propositions which we can use in a fairly simple argument. So here we have springs A and B. Both of them consist of two springs in series. A is loaded by one mass object, and the B spring is loaded by a two mass object. And let's say the spring constant is 1k. It's of course the same for both springs because they are the same spring. And let's also say the displacement for the spring A is 1x. So then we know the displacement for the spring B is twice as much, so 2x. And now the question, of course, is where is the 4 times the energy hiding in this B spring? And it's of course hiding in the spring itself, in spring constant and the displacement of the spring. Because I think those are what determine the energy of the spring. So for the sake of simplicity, we can remove these weights from the figure and just focus on the springs. In the B spring, we can take a look at the individual springs separately. So based on the proposition number 1, we know that the spring constants of these small springs, the red and the blue spring, is twice as much. It's 2k now. And both of them has displacement of 1x. Because they share the total displacement, which was 2x, so both of them now have a displacement of 1x. And now already we have kind of two tools in the B spring. We have two springs, both having 2 times the spring constant. So it's already suggesting 4, but we can also take this even further, because we can get rid of these 2k spring constants using our proposition number 2. So instead of having twice the spring constant, we can have just 2 springs in parallel, having 1k spring constants. And what we have here in B is of course just 4 springs with the same spring constants and displacements as this spring A, which was loaded by just one mass object. And this should show us that twice the spring displacement means 4 times the energy, just like twice the velocity means 4 times the kinetic energy. So I think this was pretty simple visualization or explanation. Maybe the best one I can do without any mathematics or stuff like that. So if you disagree with this video, I would really like to know why that is. Okay, bye.